2 o'clock.
All right, everybody. Welcome to Weinig USA. My name's Christian Smedberg. I'm the marketing manager here, and I am joined by Mr. Sean Pogue. Hey, Sean.
Hey, Christian.
Hey. So you guys are joining us in our tool room here at Weinig.
Yep.
So because today we're going to be talking about tool grinding. Yeah.
Lots of it.
That's right. That's right. So yep, we have multiple rooms here at Weinig just dedicated to tool grinding and training people on how to use them, and looking at various ways to grind tools. And also we have a lot of different grinders here.
That's right.
But today we're focusing on just one.
Yep, the Rondamat 960.
Yeah.
We're going to be looking at a HSK version of that machine. Again, like Christian said, we have several versions of grinders.
Yep.
But we're going to focus on this one.
So, Sean, if anyone out there is watching and they currently use knives, but they send them out or they get them in, but they don't grind them in-house, what does a grinder have to offer them?
Well, where we've seen a lot especially the last decade or a little bit more, you guys are all probably experiencing this yourself. We're getting more into the just-in-time running and producing of linear moldings, component parts for doors, kitchen cabinet work, stuff like that. Right. So we got to be able to turn these knives over faster, and that's the biggest thing, was that people maybe not have had the resources, as in folks to grind,
right?
So sure, they would sub it out to somebody such as the Weinig grinding service, or maybe a local supplier that can get that done for them. Mm-hmm. But as their needs come up to be able to service their customers faster, yes, that's when they usually decide, hey, it's time for us to take that into our own hands.
Bring it in house, mm-hmm. Right? Okay, yep, very good. So and Sean, can you today I want to have you just go into some of the cool features about this particular model, but can you just kind of tell us, how long have grinders been around in the Weinig group? I mean, we've been doing these for some time, right? We have some experience.
Absolutely, yes. And I can speak from experience that there's some other grinders out there, but you won't find a good as grinder as a Weinig grinder.
Yeah.
But yes, we've been making grinders almost as long as we've been making molders, because they are hand in hand.
They do. They go together, right?
That's right.
Yeah. So, Sean, today, why don't you walk us through the machine
okay,
and talk to us about it? And with that, let's get started.
Okay.
All right, great.
Hang on for the ride, folks. Well, the very first thing, looking at the grinder, most all of our grinders are going to look very much alike, to the extent that I had mentioned before. We have very, very old grinders. They've been around a long time. The key portion of the grinder itself, what we would refer to, especially in training classes or anything else, would be the center line, or the aggregate of this grinder. How is it controlling the wheel to produce the grinds and the angles and things that we're looking for? So the basics of the machine, the castings and stuff like that, they are, I hate to say it, they're very old design, but very, very useful and functional. So like I said, I do have some experience on other grinders, and there's a lot of things that you kind of have to tweak and juke and kind of get right to repeat what you have done on a set of knives already. It's not so bad the first time, yeah, you got it out on the floor, you produced the stuff, all right. It's the next time you set it up and come back in to resharpen that tool, that's when everything starts to rear its ugly head. With the Weinig grinders, everything has a point of reference, a fixed point, a pin, a stop pin, or anything like that, to where we can really repeat these things over and over and not have to sweat trying to find our home position on that knife again. And or what that would cause is, wasting extra wheel, wasting extra time, and of course wasting extra knife steel to try to get it back where it was supposed to be. Okay, so a lot of that, like I said, the grinder itself would look like the same as, let's say, an old 931. At first glance, kind of looks like it's all doing the same. But on this particular machine, you can see there's a few more accoutrements around for you guys that have those older ones. And if you're wondering what they are, we're going to walk you through those steps. So why are these features so key to us now is, again, I'm going to say this 1,000 times during this video, just-in-time manufacturing. So we have to, if the molders are running fast, they're changing over tools faster for shorter runs. The tool room has to react even faster than the changeovers that happen on the machine. So we've got to be able to come back to those things. So some of you guys that have the old green, Weinig green grinders, a lot of times what they had was manual adjustments. So in order to bring the wheel in or out, we had a ratcheting handle here. So the operator would have to keep moving this back and forth. It wasn't such a big deal with just using a singular wheel because that wheel wouldn't wear that much. So it was short movements, except if we were doing a rough and grind and then would swap the wheel out for a finishing wheel, such as like a CBN, and we'll touch on that later. And then you had to make large movements because you could be at the bottom end of this wheel, and the CBN wheels have a fixed diameter, so you had to spend a lot of time bringing that wheel back and forth. Very, very time consuming. Another thing that the operator would have to do is they would have to walk around the side of the grinder, break the item loose that clamps the thing in place, the aggregate, to keep us at 0, and he'd have to physically move this up or down to get the angles that he's looking for the side clearance. I don't know if you can see that, Christian. So he would just look at this center line right here and line that up with the angle or the degree that he's looking for, and then walk back around the machine. Get back in front of it to do his grinding, and then if he had to do any side clearance for the other side, had to walk back around to do the same thing. So again, time consuming. Then if you, not if, but when, we need to change the back clearance angle for a jointed machine, a non-jointed machine, even in the process between rough and finish grind, we have to change that angle. So that operator would have to walk around the back side of the machine and again, run a ratcheting handle to get those angles up and down. Okay. I just also want to point out, anytime during this video, please feel free to ask your questions, log them in the comment box, and we will certainly take care of those during this process. Okay, back to where we were. So what makes the current day Rondamat 960 grinder different than the old stuff is simply we know that the operator has a very busy schedule trying to feed these molders, whether it's just one molder at 12,000 RPM, or if it's multiple machines out on the floor, he has to keep serviced. So what we're going to do is just start through these buttons here, or switches. So this one simply runs the wheel in and out. Now with that said, I can turn it. I don't know if you can hear that or not, but there's a motor moving. It's trying to do something. This is an assist for me. So I have to push this lever down. And now if you watch right here, Christian, I don't know if you can get up in there tight enough, you can see that wheel moving to and from the tool rest. Okay, so as I bring that in, rough it in, and then I'm going to bring it in to being 20 thousandths off of that tool rest. So again, I'm staying in front of the machine. I'm not having to run around to the back side. Same thing with our side clearance now. When we're opening up the angles in here so we don't have rubbing going on, I can simply flip the switch over. Up here on top, you can see there's an air cylinder. So the movement of that from side to side can be done here. If you can see these holes, we basically have these pins that will come in and out of each of these holes to set our fixed side clearance. So when that's in, I simply flip it up, do the side clearance on that side, and I can have my pin on the other side as well. And flip it over, so I don't really have to stop and or pull out of the grind itself. I can get to bottom dead center or top dead center, simply reach up, flip it over, and I keep on grinding. All these little things is to help me stay efficient at the grinding area. The last one, you might want to slide over here. There's a degree scale down here on the bottom, and what we're doing is we have an automatic movement there just from flipping this switch. So wherever I need that degree to be at is where it will stop. Okay, and we will talk more about that later. Okay, so all of these items are designed to keep the operator in front of the machine and be very, very efficient. Okay, so with that, you can see this looks a little bit different than maybe some of the other older machines where you'd have a cradle. You would set that head and an arbor down onto kind of a horseshoe type of cradle system. This is what we have for power lock. So if we need to do a right or top cutter head, everything would reference to the right side, and our swivel would be over here. If we need to come to the left side or do a left or bottom, we simply loosen up these locks, and flip the entire unit over. Get it in the right place. And then lock it back down. So then that would be the opposite rotation for us. The cutter head I have in here right now is for a top, so we're just going to put that back home. Okay, so those will stay in place. And even paying attention to the details, this simple little cover, we must keep that over top of this area to keep all of the grinding sediment out. You can see a little tiny steel particle right there. We don't want this swivel coming over and grinding that into this seating area for our left and bottoms. So we keep this little cap over there, and it does a fine job of keeping that area clean. And again, we'll talk more about that later. So another very nice feature on this machine compared to some of the oldies is you can see there's a hole right here, excuse me. This is where our sediment, the grinding dust, metal shavings, everything goes down into filtration or a filter, which is seen right here. And we simply pull that filter out, that tray, and we of course change the filter out and put a new one in. With that said, some of the older machines we actually had to keep way out off of the wall, which was out in our real estate in the grinding room, because the filter was clean behind here, and we'd have to be able to get back in there. And it was even part of the base of the machine itself.
Sean, question.
Yes.
Jack would like to know, can you cut out steel templates with a 960?
Jack is asking if we can create or recreate a steel template on a 960. The answer is yes, kinda. We can, there is a jig that we do offer where we could put a template in the template carriage over on this side, and we can put a piece of metal in here, and then we can cut that profile out. Part of the answer why I kind of hesitated on that is because yes, we can do that, absolutely. It's even more accurate, of course, than using a file and doing it by hand. However, anytime I need to have a metal template made, I prefer an EDM template, simply because it's super accurate. And the way that cuts, also we can use a harder type of metal to cut it with the EDM, and therefore that template's going to last longer for us. Yes, it's a little more expensive, but we certainly can do it on the machine. A lot of times, just maybe going off on a tangent on that question, the reason for a metal template is generally for a very intricate profile where we got some blends coming together, but we're going to run it over and over and over again throughout the course of the year. Or we get into where we have a lot of multiple knives and we're doing a joining process where the guy standing here is trying to grind, 4, 6, 8, 10, 12 wing tools, and they got to be accurate from one to another. So there's different wheels we would use, and would certainly prefer a steel tracing pin at that point. Hope that helped. Okay, so back to the features on this machine. Another very, very nice feature from some of the older style machines of our own, of course, to now is we don't necessarily, to make a straight knife, we don't necessarily have to use a straight knife template over here, because a lot of times that template will get worn out, because we use more of one side of it than we do the other. The guys are, well, we'll just flip it around, and then we end up having a template with a point. Okay, so what we've done to correct that is simply down here, we have full range of motion of the carriage, if you can see that up top, so I can make a circle with this item. If I want to do a straight knife, I simply turn that halfway and it locks this in to where all I have is a side-to-side motion. Okay, so what the operator does is he just simply stands on the end of the machine, keeps the knife rolled over, and lets the bearings of the machine itself create our straight knife. So it's a much, much more accurate tool over a longer period of time. When we're finished with our straight knife grind, we just simply go quarter turn or half turn, and we have freed up the full movement of the machine again. Okay, that is a very, very nice item to have when you're doing a lot of planing, S4S, any kind of programs like that. You constantly have more straight knives on a setup than you will profiles. Okay, so the other thing too, again, going from the old green machines, the 30 series, let's say, If you notice, there is not a heavy gearbox hanging up here on the back end that's actually driving the wheel. The older machines had a mechanical gearbox that we had to turn a handle on to get our RPMs up and down. Even older than that, there was a step pulley system on here where we'd have to shut the machine down, loosen up the motor, put the belt in a general area that we would have to try to work within. And those were fixed RPMs. Not necessarily what works best for me, but that's what we had to work with. So now we go in and there's a separate frequency inverter that's driving the RPMs of the spindle itself, or the wheel. So as the wheel gets smaller, we have to create a higher rim speed to do the same amount of cutting as we would with a much larger or full-size wheel. And depending on the type of wheel itself too, that's going to allow us to set a different range of cutting, just due to the compounds of the wheel itself. And then some folks like myself are pretty aggressive, so I run a high RPM and really cram the knife steel in there. So others don't. So that lets everybody be flexible. Okay, another feature that comes on the machine, we have a hose here with a little squirt gun on it, and we just simply want to wash the machine out every day at the end of our shift and just get all that sediment over there towards the hole and into the filter so we can get to have a good fresh start the next morning or the following shift. Okay. We got any questions on that, Christian?
No. You want
Okay.
to go into menu?
You guys feel free, to ask any questions you want to, and even if you feel like we're going back to something we already covered, just fire it off and we'll get it answered. Okay, so phase 2 of this discussion is going to be the maintenance of the machine. Too many times we'd get a lot of calls through our diagnostics department talking and working through issues of the grinder itself. And a high percentage of the time, the answer always comes back to cleanliness. And it realistically starting here with the receiver on the HSK system. Before I dive too deep into that, I want to give you an idea that, hey, you're not stuck with the HSK cutter with these grinders. We can do both styles or all styles. So if we have a hydro tooling, if we have slick bore tooling, and we have HSK tooling, we can do all three on this machine. We simply slide this other arbor in, and of course we can put the rest of our slick bore tools on, our hydro tools on, anything else can go on the machine.
Okay, there's a question. Cody says, even with regular greasing, when I lower the grinding angle, it stutters as it moves. Is there a way to fix this easily?
If it stutters when it's moving, when it's going down, even with full greasing, a lot of times, we'll get a little bit deeper into that shortly, but there's some bolts over here on the side that we can make some minor adjustments with to allow a little more freedom of that movement. But what we also have to watch for is getting those too loose to whereas it allows the aggregate itself to move. So there's a fine line between there. So part of our daily maintenance, if you look up inside of here, if you can come around a little bit, Christian, and I have not cleaned this yet today, just so hopefully we can show you some garbage. But we need to keep these surfaces clean inside of there because that's what's clamping or holding that tool in place. So there's moving parts inside of there that we want to make sure and keep clean. So real quickly, we always want to use some kind of a cleaner that is going to evaporate. So there's a lot of different types of cleaners out there. This is just a brand that we have that's local. But the main thing is when we're deciding on the type of cleaner, we want to make sure that when we dry that up, that it actually pulls a little bit of the oil out of our skin. We know that it's going to fully evaporate and not leave any kind of a film on the metal surfaces. I'm not necessarily going to do any plugs for any companies out there, but that's just what you want to look for, is to make sure it is going to be a clean and dry surface once you're finished with the cleaner. Okay, so we take said cleaner, just spray a little bit on a rag. Take your clamping tool for this and wrap it around that point that we just soaked. And we want to stick it up inside of this receiver and just kind of roll it around both directions. Okay, and what we're trying to do is make sure, so you can see the amount of dirt that was on there. So that's not really a big problem as long as we're just running a very small cutter head. But all of our grinders are capable of 12 inches. So you imagine a little bit of dirt here versus out here on the end of a 12-inch head, and you're going to have what we kind of consider a spindle whip. We're going to have an outer round tool. Therefore, most likely it will not be parallel. So that's typically where the first thing shows up, is that a knife is not truly parallel to our table plates once we get out to the molder. Okay, so that's where we have to decide, is it here? This same receiver is on the optic control measuring stands, so we need to do our due diligence daily on that to make sure we're keeping it clean as well. Because we could be clean in here, but it's giving us a false reading off the stand. And we should always feel a very nice, slow, gentle lock as that's coming into place. Okay, so now for actual greasing of the machine, like we had talked about before, some of the maintenance stuff. One of the main things, I don't know if you can see this right here, Christian, there's a small greaser right here on the front. And what we're doing with this is we're making sure that we're greasing the pivot point of this whole cast assembly. So when we turn it from side to side, we're keeping it lubricated, things are staying fresh in there. So we just want to put the grease gun on here, just the maintenance gun with the R2 grade grease that comes in them. And we just want to flush until we see a little bit of grease coming out around this surface on the front side. Okay. In the beginning, some of our machines that we made did not have that grease point on there. So it was kind of a premature wear thing. We do sell the other parts to turn it into that, so we can lubricate this area here. But what can happen is if this gets worn, then this whole assembly can kind of move around. It's not that big of a deal, Sean, because we're clamping it, right? Yes, but when we move it from side to side, that misalignment will slam into the casting on the other side. So we got to be careful that everything is staying nice and in line. Okay, the next thing is up here on our slides, and this might get back to our other question. We have a grease zert here, which you would see, you just pump it until you see a little grease coming out the bottom. It's best to take this and move it all the way up to its maximum angle, do some greasing there, drop it down to its minimum angle, do some greasing there. That way we're carrying all the grease in between those 2 points across all metal surfaces. Okay, and then on the back side, of course, there's a adjusting rod on the back side of there coming up out of that motor, and we need to keep that wet. If for any reason you can't, or you feel like you're not keeping that wet enough, there's no reason why we can't go back in there and just put some grease on your finger and just soak that adjusting spindle on the back side. Anything to help us is best. I also find, because it's so easy to do, when we grease the actual barrel of the spindle, we can just simply pull these stops out and put them in their nice little prefab home and just turn it over to the side. When I do that, what it does is exposes 2 more grease zerts up underneath of here, to whereas we can keep the grease flowing up there. You can see both of those. And again, we got our grease gun on the bottom, and what we're looking for, and you can kind of see it, I did a little bit of greasing on this morning before I got started. You can see just a little bit of grease splooging out in that area. So as this thing's rotating around in our daily grinds and moves, we're keeping those collars and rub points all lubricated. All right. Okay. Same way on the wheel in and out, or this whole assembly in and out, there's a small grease zert over here. And that's going to feed grease up in through the dovetails that moves this entire assembly around. Okay. The one thing that can happen, stay up here a second, Christian, is people will allow too much sediment to build up. And as they're moving this around, that sediment can get caught in here and will cause these limit switches to hit prematurely. And whereas, let's say we got In the past, you know, I get a phone call and he says, hey, I used to be able to grind at 12 degrees. My machine won't get there anymore. What's going on? And a lot of times you just ask them to send you a picture and it is very, very packed up around that area. And it's just you're creating a false dead stop. Okay, so cleanliness is obviously very, very important. And it has to do with when you come into a shop or when I get into a shop, and either doing some training or an install or follow up with a customer, I can tell a lot of what I'm going to get into by how clean the grinder is. So those guys that take pride in keeping those machines clean are typically the guys that are producing good knives, and it's going to point me somewhere else in a problem. Okay? So filter, how often do we change out the filter? That should be done daily, or at least at the first of our shifts. And you also, there's a lot of different filters out there on the market. I think Weinig has roughly 3 different types that we use. It just depends on what you're grinding. Sometimes we want to have a thinner or a thicker filter, just depending on if we're doing a lot of carbide or if we're doing a lot of CBN, but using a CBN or high-speed steel, but grinding with a CBN wheel. We're making smaller dust versus a vitrified wheel is basically designed for grinding, so a roughing or hogging. So with that being said, we're going to take off larger particles. It's very similar to a molder itself. We're going to take off different sizes chips with different feed speeds. Okay, let me just come around the back side. You'll see some of these things are going to start morphing over into some tips that Sean's going to be giving you. But I just keep a couple of tools around that helps me keep all of this cleaned and brushed off. Just a standard shop brush that you can get anywhere. And then we took some rubber and put on a little scraper so we can do a nice job of not scraping something with a hard surface, but a little rubber edge on there. It helps me scoop all that sediment and stuff towards our collection point. Okay. The next thing too is when we're changing out our filters, the newer style base also gives us access to a tub. We simply roll the pump up out of the way, pull that tub out a little bit, refill with water, whatever the case may be. Or if we're just needing to be completely cleaned out. The best thing to do there is we have what we use here at Weinig, because we have grinding service and they go through a lot of coolant, is we'll just take the gun over there that comes with the machine, we'll put it right down in a recycle barrel and empty it down as far as the pump will pull, and then that way I can just hand carry the rest of the water that's left in the tub and dump it in the recyclable unit. Okay, now you can see over here on this side, okay, we have this dial indicator that's on the machine. Some of the older green machines didn't even have that. But the main point of this is to give us that repeatability that we're looking for coming off of the floor or pulling a set of knives out of the drawers, putting them in the head and going right back to the same position. This is all good at helping us maintain the alignment. So this is very much what we would use for what we call the axial constant system. And that's just basically starting a given knife or a given template to begin with, a certain value off of the edge of a would-be fence or our table plate on the molder. Either one of those items is where we're building from. Okay, so what does a grinder do? A grinder is very similar to a very large key machine. We have what's called a tracing pin or a stylus, some folks call it. But that stylus is going to follow along in the profile itself. Okay, so in order to create a one-to-one as to what this template is, our stylus or tracing pin has to be the exact same width and shape as what our wheel is. If either one of the two of those are off, we will never produce the same profile. So it's very important that we have the right stuff in the right places. So when we, let's say we put our cutter head on, we're going to do a resharpen. We simply take the template, and they all are always marked face up and where we have a reference of which side we're supposed to push towards the pin, whether it's a top or right, or left or bottom has its own setting pin. So we simply push that in, bring it over until it stops, and then lock this item down. Okay. Then we place the tracing pin in, whatever size it may be, and then align the edge of it and lock the tracing pin in. So now we're just going to be following that profile with this tracing pin on the edge of the template itself.
Sean, how
Yes.
often do you need to check the consistency of your tracing pin? Repeat the question.
The question was, how often should we check for consistency in the pin? Every time you grind or every time you go to a new profile. The easiest way to do this, and I forgot a very nice feature that we have on the machines now. So this light is very handy because a lot of grinding shops are fairly dark. So at least I can see what exactly I'm working at in the detailed areas down here. So with that light being right in there, I can see that. So back to the question. How do I do that? Check for the pin. I just simply roll that pin around because this is supposed to be a full radius. And if I see a flicker of light off of that edge, then I know I have flattened part of that pin out. And if that pin is flat in any way, shape, or form, it cannot duplicate what our wheel shape is. And therefore, we're not making the exact profile that we need to have. So what we have found is that the plastic templates, yes, they've been around for quite a while, but we always used to make our templates by hand. And again, back to our earlier question, out of metal. So we'd do a lot of filing and stuff, and then we'd have to heat up the template and then dip it in oil and then buff the edge and all that stuff. Well, it made a very slick surface, and that was awesome because we can glide across it a little easier. But it was a very lengthy and sometimes costly process. So the advent of knocking out these plastic templates is great, but what the byproduct of it that we didn't take into consideration is that this is a more aggressive edge on the plastic templates because of how the templates are made with the little teeny tiny bits in there and the stepping motors and stuff. Sometimes this would act just like a saw edge. So what we would do, or what we noticed, is that it was eating up the tracing pins too quickly. So we have a lot of things that we are in the process of testing and or have tested and have for sale. So if anybody's having a lot of premature wear on their tracing pins, we do offer several longer lasting versions of these pins. Yes, they're a little more expensive, but we have a carbide one that we're actually dealing with now and testing, and we've already gotten a year out of it. A year? So that's pretty impressive with that. So if you're doing lots and lots and lots of profiles, then it's worthy to have spend a little bit more money and have a whole lot of tracing pin. Oh, and the other side of that is we have a double-sided pin. It's radiused on both sides, whereas in the past, you guys know it's just a flat one and we never use it and it's just waste. So good and handy there. So, well, Sean, how do we keep this from being so abrasive? Just looking at this being a crown mold, you've got this pretty tall radius up in here. What I would generally do is just wrap it with a very fine grit sandpaper around something that's kind of hard. So we can just put it on there and just gently rub across. And all we're doing is looking to knock the peaks off of those bit edges or steps in the plastic through there. We just want to knock them off. So it's not so abrasive on our tracing pin and it doesn't come through in the finished grind itself. Okay, so we put that in, bring it over to our stop, lock it down. And what this indicator is telling me right now is that I am lined up exactly with the calibration point on the optic control measuring stand or the tool measuring device, which mimics the starting point of the profile out on the machine, be it the fence or the table on the molder itself. So we know that this position will measure out correctly and tell us out on the molder, I've just eliminated half of your profile movements or spindle movements to get the same thing out of the end of the machine. So again, all the just-in-time stuff, there's reasons behind it that we're controlling with just a standard grind. Okay, so as we change wheels, we also would change pins and to match that wheel. Super, super important. So some of you may notice a few things on this grinder that are a little bit different that you may have dealt with. And one of them is simply this tool caddy. It generally comes on the machine mounted up over here. Okay, that's kind of in the syrup of the messy area back there. It's just getting wet. There's all kinds of stuff getting on our tools, and then they're sticky and hard to handle. So very simply, go to your local home improvement store, buy a magnet, put it on the side of this unit, take that tool caddy off and mount it over here. It's just a magnet. So if somebody bumps into it accidentally, they're not going to tear their shoulder open. It's just going to fall off at worst. So that keeps all of my tools right here handy. Again, so I'm not running around the machine looking for stuff, because not too many people have a very long arm and can reach clear back to that factory position of the tool caddy. So these are kind of, we're going to get over into some of the tips and things on grinding as well. With that said, we have just the standard start stop on the coolant pump and the wheel itself, and then an e-stop. So there's something else here. You can see this is a digital back clearance angle unit. This is additional to the scale that came on the machine that we looked at earlier. And what this allows us to do is get right on top of the angle that we're after. Well, some people will say, Sean, does that really make that big of a difference? Absolutely. Because if we're looking at that physical scale down there, and I have a very short operator on first shift, second shift, and my last shift of the day is a 6'8", 6'9" guy, those are two completely different angles that we're looking at, and therefore two completely different grinds on the edge of the tool. So even if that scale rusted, fell off, somebody banged it, whatever happens, we still have a digital value for everyone to go to. So it doesn't matter what I'm physically looking at on the scale, I have a digital value to match up. The other importance to that is it not only does it keep the angles the same, it also allows us to not have to take off as much metal on the knife to get it back to the proper angle that was ground last time, which means I'm not wasting time, I'm not wasting knife steel, and I'm not wasting grinding wheels just to get back to there. So we're always mating up to those same angles regardless of who's standing here grinding. Okay, so that's a very, very nice option that we have. I don't know if you can see on the side over here, I just simply take a little small stack of magnets, not super high power ones, but this is a tool we will use. I'm going to show you in just a second how to change the wheel out. So again, I'm just keeping all of my operational tools that I need right here at my fingertips. Okay, so another big change from some of the older machines to the newer 960 styles and even the early 930s, mid-year 930s, let's say, is the actual clamping system on the wheel itself. Okay, Christian, if you want to slide over here, I'm going to just turn this slide a little bit. In the past, what we've had is a set of wrenches that the customer would have to use to lock his wheel on or to take it off. So we had to have two wrenches to pop things loose, and it was on what we called tapered shaft. If somebody who had some pretty big forearms and they go to lock this thing in place, the next person might not be able to get it off. Also, if one person squeezes it over too far, then they position the wheel in a different place so that when our grinding or our wheel dresser comes over to reshape this wheel, then it's misaligned between the wheel itself. So what we do now is use kind of a similar principle as our hydro tooling, whereas a hydro tool on the molder, the center piece of the cutter head, when we pressurize it, it reaches out and grabs a hold of the spindle, okay? And that centers that tool up on the spindle. Here, we're actually expanding the spindle itself to grab the center of the hub. So we just simply hold it with your fingers, roll this little bolt out a little bit, just till it wiggles some. And then we can hold the wheel and then just roll it off. So I'll show you how that works in reverse. Okay, you can see this little hole here. This whole assembly turns around and obviously threads in. So what happens is this bolt head goes into that keyway. Once we roll it around, it grabs that tool and seats it on this outside spindle edge. I don't know if you can see this or not, but there's a little shiny edge along the outside barrier of this hub. That is our actual seating surface. So it's a complete tall edge versus the old style, which was only seating around this tapered shaft or cone. Okay, so here's another tip for you guys that stand in front of these grinders all day. And if the room is dark, just take a whiteout pen or a silver marker or something like that and just put a mark where this will stop. Okay, so we've got a mark there that we can see every time. The importance of that is, if it's dark, all this stuff is black. Once you get that light blocked, you really can't see where the hole is. So now you can see that my stud on the hub is going to line up with the point on the arbor itself, or the spindle. So we just push that in. I just hold my fingers here and roll this around until it kind of grabs. And then I simply want to just grab the wheel and throw it. So what it's doing is it's pulling the spindle through my fingers just a little bit here. Now, if we look on the side, we can also take that same grease pencil or whiteout marker and put a line on the hub itself. So every time that I put a new wheel on, I just kind of throw it in place, I know where it's going to come back to, which means when I flip my dresser over, I'm always going to be dead center on that wheel. If this goes too far or doesn't go far enough, then it pushes us on and off of our true axial position. Okay, so once that alignment's been done, generally just kind of hold your fingers on both in case you feel something slip. And all we're going to do is drive this bolt in until there's about a millimeter gap between the two of there, between the bolt head and the brass piece. Okay, at that point, the wheel is locked in place. It's centered, so there's no vibration or out of roundness. And of course, when we pull our dresser over, we'll see that we're just touching on both sides. So we're maintaining the dead center point of that wheel. And this again is one of those places where a Weinig grinder really, really shines, because it doesn't matter when we go into our side clearance, we should not do anything that would affect what we've already done on our previous grind. Okay. For again, some of you guys that stand in front of a grinder every day, we have different types of diamond dressers that we put in here. What comes with the machine from the factory is just a single point diamond. They tend to wear a little bit quick, and then you have just kind of a flat, non-pointed diamond. So it does dress a little bit aggressively. What we do offer, it's called a multi-point diamond. I don't know if you can get close enough to see this or not, Christian. But basically there's a lot of little diamond particles down inside of that thing. So we have more diamond cutting less wheel, and it gives you a lot smoother feedback through the life of the diamond. It doesn't bounce, it doesn't do some of the things that a traditional single point diamond will do. So it gives the operator a lot of feel and feedback. Okay. Another thing that we do is when we have the CBN or diamond grinding wheels, we use, and these things are all in the book, fellas, but this is a chrome moly stick. So it'll simply go into where the diamond lives. So the diamond is going to dress our any vitrified wheels. The chrome moly stick will dress our CBN and diamond wheels. So we're using the same system to make sure we're making a true radius out here that's going to match up with our tracing pin. Okay. If some of you guys have there was kind of an intermediate grinder for a few years that we had that had a threaded diamond up here. And basically what we came up with in order to be able to dress our CBN and diamond wheels is a little unit that we would simply thread that big heavy unit out of there, thread this one in, and now we have simple use of the chrome moly stick or a traditional diamond. Very, very important. Okay. Now, there's been very, very many times during a training class or anything like that where people will grind a knife. Most of the time you're going to have some sort of a burr on the backside of that tool. Whether it's large or small depends on the grinding person, the wheel type we're using, the type of knife steel that we have. There's just a lot of different things that's going to happen there. So traditionally what people will do is they'll go pick up a piece of wood off of the floor or something out of the garbage, and they'll take that wood and scrape across this knife to get rid of that burr. Or they'll take a whetstone or something like that, and they'll simply rub back and forth across there until they think the burr is gone. The proper way to do it is, we've already changed the molecular structure of the steel because we put heat to it and then we cooled it right off. So we basically bent that metal around the edge. So realistically, all we need to do is just come back up across it, bend that metal back over. We just want to do this number, okay? If habit makes you go back and forth, that's fine. But to me, it's a little bit of a safety issue, especially with the power lock heads, because we have a closed loop over here on that end of the knife. And if I'm sawing back and forth on this thing and that stone goes down a little bit and gets caught in that hole and I'm already coming back, I'm going to slice my fingers across the knife. So realistically, all we have to do, break that burr off, and then we have these items that we sell. It's basically a rubberized graphite. It's very flexible. Can you see that all right, Christian? Okay. Once we have that burr knocked off and loose, then we just come in and use this rubberized graphite and just wipe across those edges. Okay. The importance of getting rid of that burr, and I mean getting rid of it, is the very first board that runs into the machine. If we leave a wiry edge on there, because of the cutting direction, it's going to bend that edge over the knife and then pound it in on the wheel or on the wood itself, and then back into the knife and cause a nick. And then what do? No, we come back to the grinding room and grind it. If you're joining high speed, that's kind of the old way of doing it, is guys would just lean on that joining stone until that nick was gone again. All that does is just take away a whole lot of run life. But if we're a single knife scenario, we have no other options but to come in and touch it off again. The pains of doing that in the past have been that they don't have the stop points around on the grinders to be able to come right back to a home position. So people didn't want to do it. They'd take a diamond file out and hit an edge and just get it done. We only got 300 more feet to go. Maybe we can get it done. So there's just a lot of little corners to cut there. And we don't have to, as long as we have a system that we can come back to and repeat over and over. Okay? So let me get this out of the way. Now, back up to here, these stop pins that we use. Some of the older ones had little O-rings, rubber O-rings on them. Those O-rings would constantly get, let's say, eaten up by the coolant and things in here and the pressure of the system coming over, and they would constantly get broken off. And then people wouldn't replace them, so then it just comes over and bangs metal against metal. So these are a nice hard poly on there. But what I want to show you is, this is kind of a big misunderstanding with a lot of folks. What do these holes represent? Okay, the very bottom hole there, if I kick it over for side clearance, that's going to give me 2.5 degrees of side clearance. The middle hole is going to be 5 degrees of side clearance. The next hole will be 7.5 degrees of side clearance. And with the pin all the way removed, we're getting a full 10 degrees of side clearance. So the good part about this is, with the pins, we can mix and match. So if we've got one side of the knife that is very thin, let's say we're getting down into a groover or something along those lines, we can come in and set that value. But then I also want to take more off of the other side because there's a lot more knife steel supporting that other edge. So I get a lot more clearance out of there. More clearance equals more cooling and a sharper tool. Christian, we got any questions out there?
So Sean, we have a question. Weinig offers a water jet service. What kind of advantages does this have when grinding a new set of knives?
Okay, the question is about our Weinig grinding service. We do have a water jet for doing pre-hogging on knife steel. That is a huge benefit to a customer or a company who has one grinderman They have multiple machines out there, and maybe he runs a rip saw as well. He's a very, very busy fella back there. So if we can keep him from just standing in front of the machine and making a bunch of sparks to remove or hog away all the excess steel for a particular profile, then that's buying him some time back. So that's where we go in and we got to purchase the knife steel anyways. So we just go ahead and add a couple bucks or whatever it is, and just water jet that entire profile out. So when the customer gets those knives, he doesn't have a whole lot of work to do to get them trued up and ready to go on the machine. So it does free up a lot of time.
Okay, next question. Is there time saving between the 960 and the R1000?
The question is there time savings between the 960 and the R1000? That's an easy one to answer. How important is your grinderman's time? Is he doing a lot of things for you? And the point of that is, if I'm standing here doing one task, I'm doing one task. That's all I can do. I'm tied to that machine. On the R1000, just to clear up what that is, it is a fully automated CNC grinder produced by Weinig, and it can take a blank piece of knife steel all the way down to the finished edge if you need, which we should. So what we can do with the R1000 is program the grind, set the heads in the machine, close the door, hit start, walk off and go do something else. I'm not tied to the grinder itself. It's doing work for me while I'm off ripping lumber for the next run, whatever the case is. Hope that helped. Okay, so how often should we grease the machine? It depends on how often you're grinding. If you're a 3-shift operation, you should probably be greasing the machine every day. If you're a single shift operation or you're grinding 2 or 3 times a week, at least do it every Friday. And like I said before, we want to run everything down to its minimums, grease all of our points, run everything out to its maximum, grease those points there as well. That way we're dragging fresh, clean grease between everything. Christian, if you want to move up here just a little bit, one of the important items about greasing the grinder is we have to grease it enough that where we're pushing all this grit and grime and the stuff that we're producing is just like wet sand, okay? So it's going to be abrasive on everything. So the more often we're pushing all that abrasiveness out, then the more we're truly lubricating the metal. Okay, when we were speaking earlier about the straight knife clamping system here, a lot of people just don't seem to know, and again, this is in our tooling catalog, but we do have a very specific wheel just for making your straight knives, so that we're not altering or distorting your wheel shape of your nice 2mm CBN that you do all your finish grinding with for your profiles. We don't want to beat up the tip of that wheel, so we just simply will switch out to, this is roughly a 10mm wide. This would be CBN. We also have them for diamond, same shape, same look. And we just simply swap them out with this wheel on here and put the smaller one on and then lock our carriage in like we showed you earlier. And that way we are only having one specific wheel to deal with all of our straight knives, and this wheel will last you for years versus beating up, a actual profiled wheel. Okay, the grease gun that comes with the machine, there should be 2. One is our maintenance grease gun, and that's what we're going to hit all these zerts with, just a standard number 2 grade grease. The other gun is a high pressure gun that has a manometer or a regulator on it that shows you what you're pressurizing to, and we do have to go through where you saw me earlier securing that wheel. We have to pre-pump or pre-fill the reservoir that we're using to push that bolt back and forth and actually expand that grease and hang onto that wheel. Christian, if you can come in just a little bit. I don't know if you guys can see this. I'll roll it around to these white lines. In the past, this area, which is the spindle itself, that used to be just a slick black surface, just like the hub. And once we get that coolant on our hands, it's very difficult to hold that thing still. So what a lot of people would do is take some kind of a tool and wedge it in there and then pull the wheel loose. Okay, that was very hard on parts up in here and on the spindle itself. So what you could see there from when he was zoomed in is those are now knurled. So it's very easy for us to hold that area and pop that wheel loose. We don't need tools to do that with. Okay. Don't know if you saw it or not, but when I pulled this cover off, there's a magnet now that's on these machines, so it's just kind of holding my hood in place there, and I don't have to worry about it being down here and putting a kink in my hose, all the things that generally would come along with that. So same thing as in the past, we just simply slip this on an alignment point, and there we go. So guys, I think we're getting pretty close to wrapping up. If anyone has any more questions, let's get that taken care of. Also, I wanted to let you know that we are definitely open for business here in Mooresville, North Carolina. We have been doing a lot of live videos, one-on-one videos for customers, be it on molders, grinders, edge banders, CNC routers, a full complement of machinery that we have. We can either do as one-on-one demos or just simply keep tuned into our site there, and you'll see a lot of nice machinery making some sparks or running some shavings. So until the next time, Sean Pogue signing off from Weinig. Y'all keep it safe out there.